From derivative, we have these results, since integration is the reverse of derivative.
Have you ever seen the orange man on the 12th day of July? Have you ever seen the brethren as proudly they march by? Have you heard the master's orders?
These are the elements of basic integration that we want to consider. The method of substitution helps us to reduce our ambiguous functions into simple ones. It is a very useful technique, whose role we can't undermine. The major problem is to know the right substitute to make. I hope this will no longer be a problem as we move on. Here is a very basic example to start with. Integral of 2x over x squared plus 3 dx. The right substitute to make in each function depends on the nature of the function. There is a trick I would love to teach you. It will help you with your choice of substitute. Let us consider our question here. The problem will become solved if you can make all sub-functions appear the same. Look at this. This is 2x. It is clearly a derivative of x squared. So, instead of writing 2x dx, it can be written as derivative of x squared. Now, we have x squared in the numerator and the denominator. This symbolizes that x squared is the right substitute. But notice that the derivative of x squared is equal to the derivative of x squared plus 3. This shows what if we pick just x squared, it will lead to a prolonged discussion. Although you can use it. Now we see that x raised to the power of 2 plus 3 is the best substitute. Let u equals x squared plus 3. du equals 2x. Convert all x to root of u minus 3. So we substitute all variables of x. Now, we just need to replace the old function with the new one, and perform all simplification. We see that 2 root u minus 3 cancels out. And we are not with an elementary integral, which can be traced to our basic integrals. From our basic results, we see that the integral of 1 over u is equal to ln u plus c. The bond of integration is now broken. So, we can just substitute back the value of u with x squared plus 3. And the result becomes ln x squared plus 3 plus c. The final answer. This same method is applicable to a wide range of integral questions. Here are the steps in dealing with integral questions that require substitution method. Firstly, think of a reasonable substitute that will reduce the question to the basic. That is the most challenging part of the substitution method. But you can get it all right by constant practice. The more you deal with integral questions, the more familiar you become with the substitutes and how to use them. After selecting the substitute, make the substitution. Replace all old variables with the substituted value. Take the derivative also, as it is part of the substitute you will need to make. Evaluate the resulting integral, then return the substituted value. That is all about the trick. Choice of substitute is the major trick therein. Practice more, and know the trick behind each substitute. This is another question requiring substitution method. The right substitution will prevent you from beating around the bush before arriving at a suiting solution. In short, the substitute to make here is by replacing 9 minus x cubed with u. By differentiating it, we see that minus 3x squared dx equals do. We substitute all these into our expression and simplify. The result comes out fine to be the integral of square root of u, which is easy to do. We integrate this using one of the basic properties of integration, and we return our substitute. Our final result becomes minus 2 over 9 square root of 9 minus x cubed plus e. The result we got after the substitute is the outcome of making a good substitute. Let's go hunting another question. Integral of sec square x over tanx dx. Another trick you may consider trivial is noticing that the numerator here is the derivative of tan x. This helps us to decide our substitute quickly. We make a substitute of tan x with u. We take the derivative, we substitute, we integrate and return our substitute, as courtesy demands. Then we are all done.
Have you heard the master's orders? Have you heard the chaplain's call? Put on your orange regalia, for we're marching through 𝗦𝗨𝗕𝗦𝗧𝗜𝗢𝗏. It is a lovely village, the finest ever seen, surrounded by sweet countryside and fields of grass so green. Our orange banners waving to show those vineyards all, that glorious day when we all march through the village of 𝗦𝗨𝗕𝗦𝗧𝗜𝗢𝗏.
Our result here is ln tan x plus e. Let's see another one. The integral of tan x dx. Can you crack the substitute? Take a minute to think about it before you check the progress of the solution. Think no further. This is how to go about it. You need to first represent tan x in terms of the sine and the cosine before taking the substitute. See the numerator, it is sine x, and it is the derivative of the denominator. The derivative of minus cos x. So, the right substitute is to make cos x equal u. And the rest comes easily.
For you've heard of old Dan Winters 200 years ago, who formed our orange order and proudly watched it grow. He said, come stand by Ulster, come stand or else you fall. You Protestants of Scotland, when you're marching through 𝗦𝗨𝗕𝗦𝗧𝗜𝗢𝗏. It is a lovely village, the finest ever seen, surrounded by sweet countryside and fields of grass so green. Our orange banners waving to show those vineyards all, that glorious day when we all march through the village of 𝗦𝗨𝗕𝗦𝗧𝗜𝗢𝗏. For he made us take a
Here comes the final result, minus ln cos x plus e. I have two more examples here for you. Integral of e raised to the power of root x over root x dx. The derivative of the power of e is 1 over 2 root x. This will cancel out the denominator. So, the right substitute to use here is by making root x equals u. Differentiate and follow our method of solution steeply. A valid conclusion is guaranteed.
that glorious day when we all march through the village of 𝗦𝗨𝗕𝗦𝗧𝗜𝗍𝗏. For old Danny's dead and gone now, he's gone to heaven above, up to that great grandmaster, that wondrous God above. And I know that on the sweetest 12th, old Danny sees us all, and we'll always march in memory when we're marching through 𝗦𝗨𝗕𝗦𝗧𝗜𝗍. It is a lovely
And finally, the integral of e raised to the power of root x over root x dx is equal to 2e raised to the power of root x plus e. Let us consider the last question here. Example number 6. We want to integrate tan cube x over square root of sec x with respect to x. When working with integral questions involving integration, an additional idea you need to understand is how to convert a trigonometric form from one form to another. In this case, it will be difficult to use direct substitution here. If you pick the wrong substitute, the question will turn out to become more complicated than it actually is. That is why you need to be careful in picking your substitute. The hint here is to convert the whole function to terms of sine and cosine. This gives sine x cubed over cos x raised to the power of 5 over 2 dx. The numerator can be written as sine square x multiplied by sine x over cos x raised to the power of 5 over 2. Express sine square x as 1 minus cos square x. From here, we look for a way to eliminate sine x. This can be done by substituting cos x with u. The problem is half solved here. By substituting the parameters, we have integral of 1 minus u square sine x over u raised to the power of 5 over 2 times minus sine x dx. Sine x cancels out, and this gives u square minus 1 over u raised to the power of 5 over 2 d u raised. We separate this to a basic integral as follows.
Have you ever seen the orange men
We integrated easily using the basic rule.
Ever seen the brethren as proudly they march by? Have you heard the master's orders? Have you heard the chaplain's call?
And we arrive at 2u raised to the power of 1 over 2 plus 2u raised to the power of 2 over 3u raised to the power of minus 3 over 2 plus e.
Around by sweet countryside and fields of grass so green.
By returning u equals cos x, our integral becomes 2 root cos x plus 2 over 3 root cos cube x plus e. And the solution is completed. The area of concentration in the whole explanation is how to choose the right substitute. Practice more integral questions from textbooks, it will improve your skill on the choice of substitute. Thanks for your time, and God bless your knowledge.
Fight till finish and win the war. I'm gonna keep on receiving.